Over 27. Oh, sorry. Let me erase. Okay. Now we say x raised to the power 6 over 27. Everything raised to the power 1 all over 3. Everything raised to the power 1 all over 3. Okay, we'll call this question 1. You want to try it?
Can you do it?
Okay. So we say x to the power of 6 multiplied by 1 all over 3. The 1 all over 3, since it's outside, is talking to everything in the bracket. Multiplied by 1 all over 3. And then over 27 raised to the power 1 all over 3. 27 raised to the power 1 all over 3. So this denominator, okay, let's treat the numerator first. Now for the numerator, we have, for the numerator, you have x to the power, let's treat the 6 times 1 all over 3. 6 times 1 all over 3 is 3 divided by 3, you get 1. 6 divided by 3, you get 2. So here we get 2. So this 2 will be here. This becomes x raised to the power 2. Why? Because from here, 3 divided by 3, you get 1 here. 3 go into 6, you get 2 here. So what we have here in the numerator will be x to the power of 2. X to the power of 2. All over 27 raised to the power 1 all over 3 means we should find the cube root of 27. Means we should find the cube root of 27. And the cube root of 27 means which number you multiply 3 times to get 27. That number is 3, right? So this finally ends up with x to the power of 2 in our numerator over the denominator is 3. The denominator is 3. So this is our final bus stop. Is that okay?
Yes.
Okay. Now let's take another question. Okay, this one we have 2 to the power of 24, everything raised to the power half equals to p to the power of 4. Find p. Okay. Now let's write this one. Question number 2. To the power of 24, everything raised to the power half equals to p to the power of 4. P to the power of 4. Find p. Now they want us to find p. Find p. So first and foremost, 2 to the power of 24. 2 to the power of 24 multiplied by half. Right? This power law. Third law of indices. So you take the inner power multiplied by the outside power, right? Then this will be equal to p to the power of 4. Now, the next thing to do is to first of all deal with this power. So 2 here, 1, 2 going to 24, we get 12. So what we get here eventually is such that it becomes 2 to the power of 12, right? Equal to p to the power of 4. Now here, they want us to find p. You know, what we'll be doing is to find find the power. Maybe x is always in the power or p is always in the power, not in the base. But what we have now is the base. This 2 to the power of 12, what number is that? We want to do it in a way, that same number, we want to have a number that you raise to power 4, it will give you that same number. 2 to the power of 12, what number will you get? Meaning 2 times 2 times 2 in 12 places, what number will you get?
4096.
4096, right?
Yes.
Okay, this is equivalent to 2 to the power of 12. This is 2 to the power of 12. You know what I want to do? Now I want to make 6. We are looking for the base. I want to make the power same. I want to make the power same so that I will equate the base. So what I want to do, this same number, what number will I have such that it will be to the power of 4? It will be raised to power 4. What number? You know this one is 2 times 2. Okay, times 2. Let's do them out and group them. Times 2, times 2, times 2, times 2, times 2. 1, 2, 3, 4, 5, 6, 7, 8. Okay, times 2, 9, times 2, 10, times 2, 11, times 2, 12. Now this is 2 to the power of 12. If we group them in 3, 3, 1, 2, 3.
It's 8.
Yeah, 4. So you see, 8 to the power of 4, right? So I'll have 8, because if you multiply 2 times 2 times 2 is 8. And they are in 4 places. Meaning I have 8 times 8 times 8 times 8. Right? So you see, it becomes 8 to the power of 4. This becomes 8 to the power of 4. So 8 to the power of 4. This same number that was 2 to the power of 12, I have changed it to 8 to the power of 4. The reason why I'm doing that is because this way, the base is P. You know, previously we always have the same base, then we equate the power. Now we have to have the same power and equate the base. We have to have the same power. So I have to change this one to a number to the power of 4. So, and we've succeeded in doing that by saying it's same as 8 to the power of 4. So here I have 8 to the power of 4 equal to P to the power of 4. Equal to P to the power of 4. Now you see the power are same. Now this time around we're going to equate the base. Before we used to say since the base are same, we equate the power. Now the power are same, we're going to equate the base. Because they asked us to find P and the P was in the base. So we have to find P now. So P equal to 8. Since the power are same, we equate there. Since the power are same, we equate the base. In this regard, for this question, since the power are same, we equate the base. So P equal to 8. And that's our answer. Is that okay?
Yes.
Okay, great. Now let's find another one. If I find anyone that has a similitude with this, I will give you to try. Is that okay? Is it fair enough?
Yeah.
This one, the numerator is not indices. If you look at it very well, the numerator is not indices. Why? Because it's q squared plus q squared. There's no times, there's no division. So you just say q squared plus q squared is 2q squared. all over. The denominator is indices. Do you want to try this?
No.
Okay. Do you want me to try it or we skip it?
No, I can skip it.
Okay. This one we can try. Do you want us to try this?
Yes.
Okay. This number 3. Number 3, we have 3125, 3125, t raised to power 125, every t raised to power 1. 3125. Then we say t raised to power 125. Then everything raised to power 1 all over 5. Every t raised to power 1 all over 5. So it's the same rule. It's the same rule we'll be talking about. So this 3125 will be this power, we talk to it, meaning we write 3125. Okay, it's like raised to power 1 all over 5, which means we're going to find the fifth root of this number and then multiply by t to the power of 125, t to the power of 125, multiply by the outside power, multiply by 1 all over 5, multiply by 1 all over 5, right? So what we're going to do with this number, we're going to find the fifth root. We're going to find the fifth root of this number, the fifth root of 3125. So we can do a long division, or you can check calculator for us. What's the fifth root of this number? Five go into 30.
I don't know how to put it on the calculator, so can I just do it manually?
Yeah, try manually. 5 go here, 6. 30 remainder 1 go into 12. 2.
Five.
Huh?
It's 5.
Okay, the answer is 5, right?
Yeah.
5 go here. 5 go here. 25. 5 go here. 5. 5 go into 5. 1. 1, 2, 3, 4, 5. Okay, so the fifth root of, so it's 5 times 5 times 5 times 5 times 5. So it's 5 to the power 5. So the fifth root of this number is 5. So that means we've solved this one. Then multiply by t to the power of 125 times 1 all over 5. Multiply by 1 all over 5. 5 go into 125, we get 25, right? So it becomes t raised to power 25. So I have 5 here because we solved this one. The fifth root of 3125 is 5 times t to the power of 25. T to the power of 25. So at the end of the day, our answer is 5t to the power 5t to the power of 25. 5t to the power of 25. Is that okay? Is that okay? Hello?
Yes, yes.
Okay, now let's take another question. This one. This one, are you ready to try this one? Find p, 3 to the power of p equal to 1 over 9.
Okay, okay.
Yeah, try first. I'll also do it, but just try. Question number 4. Three to the power of p equals to 1 over 9.
Is it -2?
Yep. Did you see what I was doing? Of course, yes.
No, no. I wasn't.
Okay. The answer is -2. So, 3 to the power of p equal to 1 over 9. 3 to the power of p equal to this 9. You can do it straight away, or you first of all break the 9 down to 1 over 3 to the power of 2. And then you change this one. We've explained this earlier in today's part. We say this 1 over 3 square is equal to 3. 1 over 3 to the power of 2 is same as saying 3. This 1 all over is raised to power minus. Anytime you see 1 all over in indices, is raised to power negative. So whatever power is here, then you put the power here. So that's how we got this. So the base, since the base are now same, we equate the power. So p equal to -2. Is that okay? This one is in one of the recent exam paper. One of the very recent one. Yeah, I saw this one in this question is in 2019 question. Let's see this one. Yeah, let's see this one. This one has a similitude with one of the questions I solved earlier on. This one has a resemblance with one of the questions we solved earlier on before we ended the first section of today. So we say question 5. We say x to the power of 72 divided by x to w equals to x to 8. So we say x to the power of 72, x to the power of 72 divided by x to the power of w equal to x to the power of 8. Will you try this?
What?
Can you try this one? There was one question I solved today that looks like this. In fact, they only changed the chemistry, but I think it's outrightly almost same thing. Will you want to try, or you want me to try?
No, I'll try it.
Okay.
Sir, I couldn't. Sorry, I couldn't figure it out. Can you do it?
Yeah. Okay. We're going to apply. We're going to apply first law here. Sorry, second law.
Do we like
Second law.
switch the x to the power of 72 to the other side so we can minus them?
No.
Or I mean add?
No. You know what we do? We apply second law of indices here. So in second law, you know, they have the same base, x to the power of 72, x to the power of w. So what we do, let's first of all solve this one using second law. So in second law, we'll say, sorry, let me erase. In second law, we'll say in second law, we say x to the power of 72, s to the power of 72. Because this is a division, we say minus. We just say minus w. We just say minus w. You see what I've done? Because they are same, you just write it once. The bases are same. They both have base x. Write it once. Because it's division, you just say 72 minus w. Do you get that?
Yes.
You now say equal to x to the power of 8. You now say this will be equal to x to the power of 8. And if that is true, you will see now the left side. This is an equation now. The left side is x, the base of the left side is x, and the base of the right side is x. So since the bases are same, again we equate the power again. We do it again. We equate the power. We equate this power.
Wait, what are they trying to find in this?
They want to find w. Find w. Find w.
Oh, I thought they wanted to find x.
No, find w. Okay, maybe I should have illustrated that. Find w. So you can see now x, this is base, is same as this base. So we equate the power. So what we have in the power, we have 72 minus w equal to 8. So what I will do, I will move w to the right, move 8 to the left. Right? Move w to the right, move 8 to the left. So if I move 8 to the left, it's going to be what? It's going to be 72 minus 8. 72 minus 8. Then w goes to the right, it becomes positive w. Why I move it to the right? Because it's negative on the left. So it's easier for us. So 72 minus 8, we get what? We get 60 what? 64, right? Equals to w. So you can rewrite it, w equal to 64. Is that okay? Do you understand it?
Yes, I'm copying them.
Okay. I want to give a similar one like this. I will mimic this problem and I'll give you to solve it.
Okay.
You finished writing?
Yes.
Oh, okay. I was waiting for you actually. Now let me give you one like this. Question number 6. Okay, this is 6. And then this is 7. This one, find U, and this one, find T. So have you been able to solve anyone?
What?
Have you been able to solve anyone?
I'm solving number 7 now.
Okay.
I finished 6. I got 70.
Okay. E equal to 70. You finish? Hello? Hello?
Yeah.
Have you finished it?
Yes, T for number 7, it's 65.
T is 65. Okay. Now let's find out.
I think.
I think I think you are right. Now let's see.
Because first I got 135, but then it didn't make sense, so I
Oh, okay.
redid it.
Okay, let's
That's
see.
why it took so long.
Let's see. We have P. Since this is division, when they have the same base, this is P, this is P, both of them have the same base, so we just subtract. Since this is division, we apply second law. So we say 81 minus U is equal to P to the power of 11. So since again they have the same base now, we equate the power. Again, we equate the power. We equate this power. So we say 81 minus U equal to 11. So move U to the right, move 11 to the left. So 11 comes to the left, it becomes minus 11. And U goes to the right, negative U becomes positive U. So 81 minus 11 will get 70. So U equal to 70. Okay, that's correct. Now let's find out about the second one. The second one is A and A, they are same base. So and its multiplication, we add the power. So you say 100 plus T is equal to A to the power of 35. So find T. So since the base again, once again they are same, then we equate the power. We equate this power. So we say 100 plus T is equal to 35. Therefore, T equal to 35 minus 100. 35 minus 100. So T is equal to negative 65. T equal to negative 65. Not just 65. Okay? T is equal to negative 65. Is that okay? Are you with me? Hello?
Yes.
Yeah. Okay. Let's go. Let's find the other questions similar to. This one is similar to what we've done before, right? We don't have to. Okay, let's try this one. This one looks brilliant. Find x. 3 to the power of x equals to the fourth root of 3 raised to the power 5. So we have 3, question 8. We have 3 to the power of x is equal to the fourth root of 3 to the power of 5. So we have this one. So this is again not difficult. It's just to follow the rules how we'll be doing it. So what I need to do, are you with me?
Yes.
So what we need to do is to say 3 to the power of x is equal to, I told you the root is the denominator. So I'll write 3, I'll write this 3. The root will always be the denominator. So I write fraction. We're going to do fraction on as the power. Now the root, whatever is here as the root, is the denominator. Whatever is the square is the numerator. Uh-huh. Now you see something familiar, right? You can see something very, very familiar. Am I right?
Yes.
Okay. What is familiar is that now they have the same base. So, like we always say, once they have the same base, we equate the power. Once they have the same base, we equate the power. So we just say x equal to 5 over 4. X equal to 5 over 4. That's it. Is it okay?
Yes.
Okay, great. Great. Now let's try another one. Okay, this one you're going to try for me. 32y to the power of 50, everything raised to the power 2 over 5. Remember this 2 over 5, this power outside is talking to everything inside the bracket. That's the hint. That this 32 is raised to power 2 over 5. Y is raised to power 50 times 2 over 5. This is how you do this. So 32y to the power of 50, everything to the power of 2 over 5. Question number 9. So we say 32 y to the power of 50 everything raised to power 1 over what? 2 over 5. Everything raised to power 2 over 5. So try this. Let's see.
That's 2 over 5, right? Not 2 over 5.
Yeah, 2 over 5. It's 2 over 5. You finish? You finish? Hello?
No.
Okay. You need help?
No.
Okay.
The answer is 4y to the power of 6.
4y to the power of 6.
To the power of 6.
Okay, let's.
Sir, can I go?
Okay. Okay, you go and pray while we trying to solve it. Okay. The fifth root of 32 is 2. Fifth root is 2. So 2 to the power of 2 times y. And here we have y. 15 times 2 over 5. 2 here, 5 here, 1, 5 here, 3. 3 times 2, 6. So y to the power of 6. So 2 squared is 4. So we get 4 y to the power. Okay, when she found the formula, okay? Good. And how we do it?
It's okay.
So let's quickly take a look at. We've done this one. Okay. We've also done this one. Okay. The one we did when you went away, let's explain it. Okay, you've done it as well. So you were right. We found out you were right. So quickly, let's see if we can find a similar question. Okay, we have this question. Simplify 64q to the power of negative 2, everything to the power of half. You can do this one, right? 64 q to the power of negative 2, everything to the power of q to the power of negative 2, q to the power of negative 2, then everything to the power of half. You want to try, or you want me to go ahead?
No, I'll do it.
Okay. You finish?
Yes. 4 over Q, 2 over 3.
4 over Q
To the power of 2 over 3.
to the power of 2 over 3. Really?
I don't know, I think.
Okay, let's see. So,
Oh, is it 3 or 2? Oh my god. Never mind, I'm gonna redo it. I thought it was 1 over 3.
oh, okay. Let me check the question. Yeah, it's 1 over 2. You finish?
Yes, it's 8 over Q.
Is what?
8 over Q.
Yup. 8 over Q. Because we find the square root. Anything raised to power half means find the square root. So if you find the square root of 64, you get 8. And then you get this Q. You take a look at this. We have these two. We cancel these two. So it will be Q raised to power minus 1. Q raised to power minus 1. So anything raised to power minus 1 is same. If you say Q raised to power negative 1, it's same as saying 1 all over Q. It's same as saying 1 all over Q. So this is like saying 8 times 1 all over Q. 8 times 1 all over Q. So 8 times 1 is 8, and then Q over Q. So this is it. Is that okay? Okay, let's see another question. I know you're tired, but let's just also finish. Now let's take a look at this. 5 to the power of 7 divided by. This one has similitude with the one we solved today. Will you want to try this?
No.
You don't want to try? You want me to try?
We already did it. If you want to try, it's fine.
Oh, okay. Okay, we say 5 to the power of what? 5 to the power of 7 divided by 5 to 9, p to 2. 5 to the power of 7 divided by 5 to the power of 9 equals to p to the power of 2. This one is a bit different. This one is a bit different. You know why?
Why?
Because the base will not be same. Here, we used to have the same as 5 here, 5 here. If I scroll up, you see. The one we did that has that same thing, you see, P, P, P. all the base were same. You remember? Look at this one. X to the power of 72 divided by x to the power of w equal to x to the power of 8. All x, x, x. But this particular question is different. This particular question, yes, these two they're same, but the p is not 5. Do you get it now? Do you understand?
Yes.
Yeah. So we first of all we apply the second law here. So we say this will be 5 to the power of 7 minus 9. 7 minus 9 equal to p to the power of 2. So this will become what? 5 to the power of negative 2 is equal to p to the power of 2. Equals to p to the power of 2. So this is kind of like same, except that we have minus 1 here. This is same as saying 1 all over 5 to the power of 2 equals to p to the power of 2. Okay, so we can equate this one, but in this regard it will not be just 5, it will be 1 all over 5. Okay, because this whole thing, p will be 1 all over 5, because this whole thing is same. See, it's same as saying 1 all over 5 everything to the power of 2, because 1 to the power of 2 is 1. You know, that's why even if it's not here, the power of 2 is not here, it's still the same thing. 1 to the power of 2, 1 to the power of 2 is 1. 5 to the power of 2. So we can put this power for both of them, like for both of them. It doesn't change the chemistry. It doesn't change the bond, the stoichiometry of the equation. So it remains the same. Why? Because 1 square is 1. So, and then it gives a same power. It enables us to put the left side with same power with the right side. This only enables us to put the power to be same. Now once the power are same, then we now equate the base. You remember that? Remember that, right? Once the power are same, we equate the base. See this power, they're same. We said the moment the power are same, then we equate the base. So p is equal to 1 all over 5. P equal to 1 all over 5. Only because here this was negative 2, not 2. If here was just 2, we would just say the base, the power are same, p would have been equal to 5. If here was 2, if there was no negative here, if here was just 2, p would have been equal to 5. But because this is 5 raised to power minus 2, then we put it in this format. We say negative means 1 all over 5 squared. And then we change the stoichiometry of the equation, the dynamics of this, because it gives the same output. So what we do is we say, even if we say 1 square will be 1. So we put it together as a bracket, we square both of them so that we will have same power, and then we can equate the base. Is that okay? This question is a bit tricky, but it's easy.
Okay, can you scroll up so I can copy it?
Okay.
Wait, why is P not 2 then?
Why is P
Is it
not
because they
2?
don't have the same bases?
Why is P not 2, right?
Yeah.
Okay. P is not 2 because the power are not exactly same here. No, P cannot be 2. P cannot be 2. You know why?
Why?
P is a base on the right? You know we have base and we have power. P is a base, right? We can only equate power and power, base and base. For this question, the power, they are the same. They look the same. So we got to equate the base. However, before we do that, there's a negative here. We need to treat it because there's no negative on the power of P. We only have P to the power of 2. So there's no negative. There's no negative on the right. We have P to the power of 2. But here we have 5 to the power of negative 2. You know, when I say when the power, if the question was like this, 5 to the power of 2 is equal to, if this, like, let's say you solve a problem and you go to this junction, 5 to the power of 2 equal to P to the power of 2. Now, the base are not same, but the power are same. And the moment the power are same, we equate the base. The moment the base are same, we equate the power, vice versa. Is that okay?
Wait, so if the bases aren't same, then the power is...
The bases are not same, but the power are almost same. It's just that there's a negative here on this power. So because of that, we treat it again one more time. It's like you treated something is almost about to heal up, but it's not completely healed up. So you treat it a little bit, just a little bit, to put it in that state. So here we have 5 to the power of negative 2 is equal to P to the power of 2. It's almost, the power almost same. So we just need to do one little trick here and there and make them same. Now we already know that 5 to the power of negative 2 is equal to 1 all over 5 to the power of 2. We already know this from indices. We already know this. Now what again I have to do, because this is not still equal to, it's not equivalent to P to the power of 2. It's not equivalent. So to make it equivalent, I have to let this power to speak to both the numerator and the denominator. Now this is possible because the numerator is just 1. 1 to the power of 2 is still going to be 1. So to make it dynamically same, we just say 1 all over 5 to the power of 2. Both of them, we put them together to the power of 2. Now, you have not done any harm. Why? Because even if I say 1 to the power of 2, I will still get 1. I will still get this 1. So now it is now both sides are now having the same power. Both sides are now having the same power. You have 1 all over 5 to the power of 2 is equals to P to the power of 2. Now the powers are exactly same now. There is no negative anymore. The power is exactly same. Since the power is exactly same, you equate the base. You say P will be equal to 1 all over 5. P will be equal to 1 all over 5.
Okay, got it.
Okay, great. And let's see if we still find a few questions. And
can we just do one more question?
Yeah. We can do one more question and then we'll be good to go. But we have to find a question that will worth it, right? I've seen one here, but let me see if I'll find a question that is tougher than this, because I know you can do this. Because this is 27 to the power of 1 all over 3, x to the power of 12 times 1 all over 3. So 27 to the power of 1 over 3 is to find the cube root of 27. Is to find the cube root of 27, which is 3. And then x to the power of 12 times 1 over 3. 3 go into 12, you get 4. So this becomes 3x to the power of 4. So that's it for this question. So let's find something that is unique. Find P and Q. Okay. Do you want to try this?
Can you do it?
Yep.
It looks hard.
Yeah, it looks hard, right? I'm going to do it, but I want to look if there's anything that is harder than this. I know this type we did this. Oh, this question repeated itself. We did this question, remember? 256 w raised to power 250 everything over 1 over 4. You remember?
Yeah. That means some of these questions are going to come in the exam.
Yes. This one is easy. This is 0.125, which means 0.125 is 1 over 4 is 0.125.
Wait, sir, can I ask you a question?
Yeah.
Because you're a teacher, so most of our, like any quiz we have in school, it's the teacher tells us to study from past papers, and every time we study from every past paper,
Yeah.
Usually the one for like 2020, 2021, 2022 are, you have to pay for them to get the questions. So I study from like 2019 until like 2009, but somehow the teachers get questions that I've never seen before. So do you think they get them from the ones we have to pay for?
No, you can actually download past paper for free. Even 2022, you can see
No, I
download.
know that. Sometimes I do find ones that are already practiced. I'm just saying some are very hard, and I can never find them, like whenever I practice.
Yeah, because you know there's October, November papers. The questions are harder. Maybe the teachers are getting them from the October, November exams.
Maybe, okay. Because
Yeah.
I usually just get topical questions. I don't go looking for them in past papers because it's just a hassle. So
Okay. I think they're getting them from maybe October, November exam. You know there are so many questions. In every year, in let's say there are 3 exams in a year: February, March, and there's May, June, and there's October, November. Now, out of these three, there are for three variants for every single one. Variant 1, variant 2, variant 3, and even sometimes to variant 4. So the questions are a lot. Probably you may not have come in contact with some of those questions, but they're there. But the way we're doing it, because like Save My Exams or the one you showed us, the other link, whether the Guru one, they pick all these questions for like, I make it like topic. So all these questions from different past papers, the hard level, the easy level, the medium level, they put them all together and then these are the things we're solving. So if we keep doing like this, then we'll be very familiar with most of the questions, especially if we don't forget. Like everything we've done, if you keep tap of it, you're gonna find it easy. Okay, let's go and do that question. If we still have time, we can do this one. But if you say
no, can we just do one?
Please? Okay, let's go and do that question. Because that question is harder. Then I can explain this one without doing it. Is that okay?
Okay.
Let's do it. Is it find the value of P and the value of Q? Okay, let's write this question. 3 over 8 raised to power 3 over 8. Wow. Then 3 over 8 raised to power 1 over 8. Okay, let's question number 12. Okay, 3 over 8 raised to the power of 3 over 8 times 3 over 8 raised to the power of 1 over 8 is equal to, let's see the question, is equal to P to the power of Q. It looks hard, but it's not hard, hopefully. Okay, now what we have, you can see 3 over 8 is the base here, 3 over 8 is the base here. It's a find P and Q. So this will be 3 over 8 to the power of 3 over 8. Then you know this one will be, because it's times, you have to add that, because the bases are same, right? Remember, these two bases are same, 3 over 8 and 3 over 8. So, and this is times. We use first law of indices. This is fractional indices. You now say plus 1 all over 8 plus 1 all over 8 is equal to P to the power of Q. Now, this way, we will do this simple 3 over 8 plus 1 all over 8. That would be 4 over 8, right? This will be 4 over 8. And 4 over 8 is 1 all over 2. 4 over 8 is C as 1 all over 2. So we have here 3 over 8 to the power of 1 all over 2. We close the bracket to the power of 1 all over 2. Is equal to, this P will be equivalent to this base. They have to be equal in order for us to solve. So P will be automatically equivalent to these two bases. P will be equal to 3 over 8. Is that okay? So my P is equal to 3 over 8. So I write 3 over 8 here, raised to power Q. We don't know what Q is. We're going to find Q. Now, since these two bases are same, we equate the power. Since the two bases are same, we're going to equate the power. So we equate this power. So Q will be equal to 1 all over 2. Q will be equal to 1 all over 2, while P is equal to 3 over 8. Yeah, the question is, why did you say P is 3 over 8, right? Do you have question?
No.
Oh, did you understand what I did? Or you just want it to end?
No, I'm listening. I'm just copying.
Okay. So P, this one has to have the same base with this in order for us to find this power, this Q. We cannot find Q if we don't know P. So, and P has to be same base with the left. P has to be same base with this one, 3 over 8, in order for us to find Q. So P equal to 3 over 8. So we put 3 over 8 in place of P, and then we're able to find Q. We equate the power because the base will be same. Then the base have to be same in order for us to find Q, the power. Is that okay? And even if you say, okay, let's keep the P in another note. Let's say we write it like this, the way it is: 3 over 8 raised to power 1 all over 2. We want to keep the P equals to P to the power of Q, right? So Q has to have the same power with this one. So meaning Q have to be half, raised to power half. Then we can now equate the base, which means P will also be 3 over 8. Do you understand? Whichever way you go, you're still going to find the same answer. That's my point. Okay, so we're going to stop here for today. Thank you very much for your time.
Thank you, sir. For tomorrow's class,